Hello everyone. Today we're going to be going over rotational symmetry, which is the last topic in our similarity and transformations unit. So let's go through a few definitions. If you can rotate a figure around a center point by fewer than 360 degrees, and the figure appears unchanged, then the figure has rotational symmetry. The point around which you rotate is called the center of rotation. The number of times a figure fits into itself or onto itself in one complete rotation. I should have written rotation. Rotation is called the order of rotation. A shape that requires a rotation of 360 degrees to return to its original position does not have rotational symmetry. The smallest angle you need to turn a figure onto itself is called the angle of rotational symmetry. Which is also known as the angle of rotation. Rotation. That should be an O. The relationship between order of rotation and angle of rotation is given here. So the order of rotation is the number of degrees in a full circle divided by the angle of rotation, or you can flip these so the angle of rotation is 360 degrees divided by the order of rotation. Right, so let's look at an example. Each of the figures below has rotational symmetry. Draw the center of rotation, state the order of rotation, the fraction of a turn, and the angle of rotation. So this first one here, we rotated around that point. If I rotate it a little bit this way, notice it matches up with itself. Rotate it a little bit further, it matches up with itself again, and completing the circle, it matches up with itself at the end. So the order of rotation is 3 because it fits on itself 3 times in one full rotation. The angle of rotation, given by this equation up here, 360 divided by 3, so that would be 120 degrees. And the fraction of a revolution is just 1 over this number. So I have to make a third of a turn to meet the first time that it matches on itself. So that would be 1/3. Alright, moving on to the next logo. If we rotate it 90 degrees, it's not quite mapped onto itself. The blues aren't where they should be. If I rotate it 180 degrees, that's where it should be. 270, not quite. 360, we're back to start. So it fits onto itself twice in one rotation, so that's the order of rotation. The angle of rotation is 360 divided by 2, so that would be 180 degrees. And the fraction of a revolution is 1/2, because I have to rotate this half the way around to match it onto itself. Moving on to equilateral triangle, I need to rotate it around that point. So if I rotate it a little bit, okay, it looks like it should match up there. So there's once, rotate it again, it matches up again, and the rest of the way, there we go. So the order of rotation here is 3, which is also 120 degrees angle, and 1/3. Moving on to the square, I would rotate it around the center. So I can rotate it 90 degrees, it matches onto itself. 180 degrees again, 270, it's on itself again, and completing it, we match up perfectly. So there's 4 times that we match onto itself, right? So 1, 2, 3, and 4. So the order of rotation here is 4. 360 divided by 4 gives us the angle of rotation, which is 90 degrees. And the fraction of a revolution is 1/4. Now for a regular pentagon, center is there. If I rotate this, I can rotate a little bit. There it matches up, right? A little bit further, again, 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 and finally back to the start. So we got once, twice, 3 times, 4 times, 5 times. So the order of rotation here is 5. 360 divided by 5 is 72 degrees, and that would be 1/5. So note the order of rotation of a regular polygon is equal to the number of sides it has, which is also equal to the number of lines of symmetry it has. So notice 4 sides on a square, that's the order of rotation, so on. Okay. Moving on. So example number 2, we need to state whether the 2 triangles are related by line symmetry, by rotation symmetry about the origin, or both. So it looks like, just remembering from last time, we have some line symmetry here, right? So if this is, try to draw that better. That's a mirror, right? If you're looking at this triangle reflected here, you would see its image like that, right? So this point maps to that one. They're equidistant from the center there. Same thing here is 1 distant from the mirror line there, and then this is 4. That's 4 too. So it's got some line symmetry there. That's great to see. So it for sure has line symmetry. So maybe I'll just write that. Line symmetry about y equals 0. Sorry, x equals 0. Okay, and then to check that it has rotational symmetry, I have a bit of a trick for you. So if you grab a scrap piece of paper and just lay the paper over top of this image, if you're going to do this on the computer screen or iPad or whatever, just make sure that there's no debris or anything, no sand, that sort of thing, so that you don't scratch your screen. So line it up like this. Draw a little origin here around like where you're going to spin this shape. And then you're going to you trace the shape that you have. So we'll trace this. Now, when you trace this shape, so you go like that, and like that, and like that, right? When you flip this piece of paper over, here's what it would look like on the back, right? So you have a light, you'll see sort of an image through the paper of the triangle that you just traced. And what you're going to do, so if you need to draw a new image of this triangle, what you can do is shade darkly the line that you've drawn. So if you shade this on the back, we're going to kind of make a carbon copy. So once that's shaded in, you can flip it back so that you line that up with the origin, and then you've got your shape drawn, and then on the back here it's shaded. You take the paper and like grab it by a corner. You're going to place a pencil or something sharp at the origin, and you're going to spin the corner around your pencil. So you're going to hold your pencil in place, grab a corner and spin it whichever direction you need to go. So what it'll do is, do like that and like that. So if you wanted to rotate it, for example, if you wanted to rotate it 180 degrees, there's 90 degrees clockwise, there's 180 degrees clockwise. Now, If you want to transfer that onto the paper, obviously you won't be able to do this on the computer screen, but if you have another piece of paper in behind this blank piece, you can draw, like press hard along the shape that you originally traced, and when you remove this piece of paper, there will be an impression or like a carbon copy of the shape that you drew. So, I mean, you can see that this doesn't quite match up with what this one over here is. It's like, it's close, but we need to do a reflection about the line y equals 0. So we don't have rotational symmetry. So no rotational symmetry. Okay, so maybe just clean that up a bit. Right, next, rotate the polygon shown 90 degrees clockwise. So we're going to do the same kind of procedure. Take a bare sheet of paper, draw a little plus sign at the origin where you're going to spin this shape. We need to rotate this 90 degrees clockwise. So take the paper, right, line it up, trace as best you can. Okay, good enough. And what you're going to do is plant your pencil here, grab a corner of the paper and spin it. So if we're going 90 degrees clockwise, we're going to go like that. So that's where the shape ends up. And if you've shaded the back of your paper, you can make a carbon copy by just tracing the original shape. And the reason for this plus is it just gives you a nice reference as to how far to rotate. And you just keep rotating until this plus is sort of in line with the axes again. And then you press firmly along here so you can trace this shape onto the paper in behind your blank piece of paper, and then there it is. So that's what we needed to do. Rotate the polygon 90 degrees clockwise. That's where it should be. Alright, next, let's complete, oh, hang on, I didn't answer that question. Oh, yes, okay. So I thought it was sort of a continuation of that one, so we're good. Rotate the polygon, did it. Good. Okay, next, complete the following table for the figures shown. So here we have a shape, type of symmetry. It doesn't look like it has line symmetry, because if I reflected this about this line, this is a white part, this is a gray part, so if I reflected, this isn't white, right? Same thing here. This should be, these colors should match up. Also, there's an arrow here, there's no arrow there, so that doesn't quite work. Similarly, if we had a line of symmetry like that, it doesn't work here either, because we would have something like, it would need to look like that, and this would have to be colored, but it's not. So looks like no line symmetry, but look at this, we can rotate it onto itself, so it's got rotational symmetry. So rotational symmetry. Number of lines of symmetry, there are none. Direction, not applicable. Okay, the order of rotation, I can rotate it 180 degrees, and then it's there. Another 180, it's there. So in a full rotation, there's once, there's twice. So the order of rotation is twice. The angle of rotation, we take 360 divided by the order. That gives us the angle of rotation, which will be 180. Right, moving on to the next shape. Notice I can rotate it onto itself once, twice, 3 times, 4 times. So it's got for sure rotational symmetry. Rotational. But it also has line symmetry. So I can split this like that, and the image of this would match up with this, right? So you could fold this in half, and this point would reach that point, this would meet that, right? It would be perfectly lined up. Okay, we could also do like this, so we could fold it in half left to right. That would work out. This point would meet that point, right? That corner would meet that corner. They'd be perfectly lined up. We can also do lines of symmetry like this. So if we folded it in half this way, this point would meet that point, this would match up with that, that one would line up with that, and we'd have perfect overlap. So we could do it that way. We can also fold it in half like that, so that lines up as well. Those corners, these ones, right, folded in half that way, perfectly lined up. So we have in total 1, 2, 3, 4 lines of symmetry. So rotational and line symmetry. The number of lines of symmetry, there's 4. Direction, horizontal, but also vertical, and oblique. There are 2. Okay, order of rotation, so I guess we have, just keep it inconsistent. Order of rotation for the shape, I remember I could rotate it 4 times and it matched on itself. So that's 4. 360 divided by 4 gives us the angle of rotation. So that's 90 degrees. That one's done. So what is the angle of rotation symmetry for a shape with an order of rotation of 6? So we just do 360 divided by 6, right? 360 divided by 6, so that's 60. And what's the order of rotation symmetry for an angle of rotation of 40? So the order, we just do 360 divided by the angle of rotation, which is 40 degrees. 360 divided by 40, that's 9, right? So that's it for the day. You can do these questions that follow the notes. So you can I'll just give you a little bit of a preview of what you got to do for your homework. Describe the rotational symmetry and line symmetry of each shape. So take this rhombus, put the center of rotation there. No good if I rotate it 90, and then it matches when it's 180. So order of rotation there is 2. So yeah, practice those questions. You can get started on the review that follows. So review, and that's it. So that basically concludes the unit. Please make sure that you review in advance of your final assessment coming up soon, and I'll see you next time.